The name of Allah, the most gracious, the most merciful. Hello everyone, my name is Majd Murjan. I'm a freelance structural design lecturer engineer, graduated from the University of Aleppo, Faculty of Civil Engineering in 2005. You are welcome in this new course in the field of earthquake engineering, which is Seismic Analysis Approaches Course 1, How to Choose a Linear Method Using ETABS. Actually, and do a lot of earthquakes which were happened this year in different countries around the world, especially Arab countries, Morocco, Syria. I have decided to conduct some courses in this field to enable structural engineers to design their structures against these shakings and protect human lives. The next courses will be Course 2, Linear Static Method using ETABS, Equivalent Lateral Force Procedure, ALF. Course 3, Linear Dynamic Method using ETABS, Modal Response Spectrum Analysis, RSA. And the last one will be Course 4, Nonlinear Static Method using ETABS, Pushover Analysis. In this course, I will teach you how to utilize ETABS to select between the linear seismic analysis methods according to the American Code ASCE 716. We will practice the ETABS model of a real commercial tower project at Jeddah City in Saudi Arabia. We will brief the seismic analysis approaches, the seismic resistance systems. We will learn the irregularity of buildings, seismic design category of buildings, seismic ground motion values, time period of structures. Please be noted that this course will be via 7 interactive web sessions, 1.5 hours per session. We need also some software and language and knowledge of earthquake engineering. Please check this brochure for all the required information. This course is divided in 4 sections: the introduction, the example, which will be an ETABS model, and as I mentioned earlier, we will go through the steps of the selection criteria. Conclusion, we will conclude the results of ETABS model and choose the right method, and also we can see the references which I based my course on it. Actually, this session will be on the introduction, which will be on the brief on seismic analysis approaches. We will see what are the linear seismic analysis approaches and nonlinear seismic analysis approaches. Before going to the approaches, let's have a look about some important definitions and formulas, like here the formula of motion. Every mass, when it's vibrated or displaced or rotated, whatever, under the earthquake shaking, this excitation force, earthquake shaking, is equal to the inertia force plus damping force plus stiffness force. Natural period of the structure. It is the most important dynamic property. If we have one floor story building, and let's see this mass was moved from this side up to this side, then from this side up to this side. Now this time we called it as T, the time period. This T is dependent on the stiffness of the structure, which is how the structure can resist the deformation or rotation. Now, as much as the stiffness is small, like here in high-rise buildings, and or here the mass, we see here the mass was increased So as the stiffness is smaller or the mass is bigger, the T will be increased. Modes of vibration or mode shapes. Actually, during earthquake, every structure will be vibrated in different mode shapes depending on the time period. As we can see in course number 3, the response spectrum analysis method, each number is equal to number of stories multiplied by 3, and here we can see about the degree of freedom. Stiffness and rigidity both measure the resistance of element to deflect or rotate, and we have here the spring constant or stiffness constant. Its unit is Newton per meter, which is a unit force per unit displacement, and express the resistance to deflect. Now let's talk about the performance-based design methods or performance-based engineering methods. It relied on the nonlinear analysis methods to determine the realistic behavior of the structure. As we can see here, we have the intermediate occupancy, life safety, and collapse prevention. Immediate occupancy. After the earthquake, this building keep its stiffness of the elements to resist lateral and vertical loads, and only small damages were happened and no hazard on the life of the people. Life safety. During these elements has achieved the plastic hinges, and there are a lot of damages on the building, but also no hazard on the life safety of the people. For collapse prevention, at this stage, this building must be evacuated because it has very big hazard on the life of the people. Now let's talk about these approaches, linear analysis methods. We have the linear static method and linear dynamic method. Linear static method, ELF procedure, equivalent lateral force procedure. Linear dynamic, we have model response spectrum analysis, response history analysis. During this analysis, the linear analysis methods, we calculate the structural response within the elastic region. Inertia forces are calculated as an equivalent static forces. Here we can see F equal to K by X, stiffness multiplied by displacement, and every response will be in this region, elastic region. For nonlinear analysis methods, they are used for buildings which will experience significant inelastic deformation under large earthquake, and calculate the structural response, strength and stiffness deterioration associated with the inelastic material behavior and large displacements. We will deal it differently from the linear analysis methods. We have pushover analysis and nonlinear static method, and we have nonlinear dynamic method response history analysis. Now let's talk about this linear static method, equivalent lateral force procedure. It is used for regular buildings, masses and stiffnesses, and there is specific formula to generate static force which is equivalent to the real earthquake force. As you know, this real earthquake force, it is a dynamic force dependent on time, and it is not static but dynamic. This is the earthquake, and here every floor will resist like this, and this distribution on floors will be a triangle. So every story will get some share of this shear force, and then it will be distributed to the resisting elements based on their stiffnesses. Now let's talk about this linear dynamic method, model response spectrum analysis. As we see here for this figure, we can see this spectrum, different accelerations for different time periods. This spectrum was formed for different buildings under different shakings in different areas in USA, United States of America. This method is used for non-regular buildings in masses and stiffnesses, and it is more general than the lateral force procedure, and the structural response will be presented by modes of vibrations. As we saw earlier, this shear force will be also distributed as triangle, their first mode of vibration, and the modal analysis will be conducted to calculate the maximum response of the structure, even element forces or displacements, and the shear forces, drifts at stories will be calculated and will be combined to gain the total response. Another linear dynamic method is the response history analysis, which is more convenient for non-regular, taller high-rise buildings with T is more than 1 second, and this response will not controlled by the first mode of vibration, but we have multiple vibration modes affect the behavior. It depends on analyzing the dynamic response under real recorded acceleration at the site studied. It is similar to response spectrum analysis for the input of masses and calculate the response. Now, what about the nonlinear analysis methods? Let's start with the nonlinear static method pushover analysis. It is applicable for regular low-rise buildings where T is less than 1 second and the response is dominated by the first mode of vibration. It is accomplished after finishing the linear method and designing elements by step-by-step analysis. Now, the concept is that increased forces are applied on the model until collapse, or lateral forces are applied until a target displacement is achieved, and during that we observe the performance levels of the structure. Nonlinear dynamic method, response history analysis. The criteria of using it is the same as for the linear dynamic method, response history analysis. Now, gents, this first session was finished. In the next sessions, we will discuss and discover the 4 steps of the selection criteria between the linear methods as per American Code ASCE 716. I hope you enjoyed it. Please do not hesitate to contact me for any information. Thank you for your time and your watching. See you soon. Goodbye.